In this video, we're going to discuss how we can negate conditional statements, and this is actually going to be very important in our study of analysis. Before we do that, let's remember what the negation of statement is. The negation is a statement that is true exactly when the original statement is false. And I want to go back to our first example, which your parents promise you £1,000 if you got a very good mark in analysis. So remember, if your parents tell you that if your analysis mark is 80% or more, then we will give you £1,000. Then the question is, when are you allowed to be angry at your parents and say that they lied to you? And we had these four options. And if you remember, if you got 95% and you got the money, you're happy. If you get less than 80% and they gave you the money, you're happy. Your parents are very generous and maybe they thought that you worked hard enough. It's good, you got the money. If you get less than 80%, you got 60%, and your parents don't give you the money, you're upset because you didn't do well analysis, but you cannot be angry at your parents. So the only time we were angry at our parents was when we got 90% and the parents didn't give us the £1,000. Of course, are you allowed to be angry at your parents if you get 85 and they don't give you the £1,000? Yes. Could you get 80% and still be angry at your parents if they don't give you the money? Yes, because they would have broken their promise. Their promise was that if you got 80% or more, then they will give you £1,000. So the moment you get anything that's 80% or more, like even if you just get 80%, you should expect a £1,000. Otherwise, you could say that they lied to you. And that gives you an idea of how to negate the statement. So the negation of the statement is that your analysis mark is 80% or more and your parents don't give you their £1,000. It's just the case, it encapsulates all the cases when you are allowed to be angry at your parents. Okay, very good. Now, let's take a look at a math example. So, we want to write the negation of the statement if n is a prime number, then n squared plus n plus 73 is prime. And here, okay, if we do the same thing as before, well, could it be the negation that n is a prime number and n squared plus n plus 73 is prime? If you want, pause and think about it. Is this a correct way of negating the statement, or are we missing something? Well, here, what is n? If I were a marker and you answer to this question with this, my comment, I'm 99.9% sure I would write, what is n? Remember, this is not a statement because we haven't fixed n, we haven't quantified n, we have no idea what n is. It's like, oh, this is not a statement, what am I doing? So, how can we fix this? Well, remember that conditional statements often have a hidden universal quantifier, and that's where we went wrong. Because what we actually meant when we said this statement is that for any integer number, if n is a prime number, then n squared plus n plus 73 is prime. And now, okay, if we want to show that this is false, if you want to catch me in a lie, which is, how I think of negating statements, if you want to say, hey, no, you lied to me. Maybe I didn't, maybe this is true, I don't know. But how can we negate it? Well, we need to find an integer for which that condition in pink is not true. So the negation would be there exists an integer such that, and well, the negation of that pink bit is precisely what we wrote before. So then what we need to say is that there exists an integer number such that n is a prime number and n squared plus n plus 73 is not prime. Okay. Something very, very important that I want you to take away from this video. If you don't remember anything from this video, please at least remember this. This is extremely important. Students make this mistake again and again and again in exams. I do not want you to make the mistake. The negation of a statement of the form if something then something is never ever a statement of the form if something then something. So again, the negation of a statement if something then something is never ever ever a statement of the form if P then Q. Okay, that being said, let's go back to that statement of if n is prime, then n squared plus n plus 73 is prime. I asked you in another video to think about whether this was true or false. Let's take a deeper look at it. Well, something I can do is I can check some values of n to get an idea. So here I started looking at prime numbers, and I did. Here we have a table. That colorful table has all the prime numbers up to between 1 and 500. So I took the first 20 of them. So here you can see 2, 3, 5, 7, 9. And all of them you can see up to 17. N squared plus n plus 73 is 421. And if we go there, we can see the bottom line, again orange, we have that 421 is a prime number. And I did the same thing for all the first 20 prime numbers, so from 2 to 71. And all of them turned out to be prime. If you Google it, 5,153 is a prime number. Trust Google if you don't trust me. Okay, now, does this mean that the statement is true? I tried for the first 20 prime numbers and it always worked out. But how do I know that if I continue doing this, it's not going to break, right? I said that it has to work for any prime number that I pick. So, okay, let's see. What happens if n is 73? Well, when n is 73, then n squared plus n plus 73 becomes 73 squared plus 73 plus 73. This is equal to 73 times 73 plus 1 plus 1. Okay, that's 73 times 75. So we're saying that n squared plus n plus 73 is equal to 73 times 75. So it cannot be a prime number. So the statement was false. That's mind-blowing. We tried 20 numbers. Actually, if you tried all the integers between 1 and 72, you're going to believe that indeed that's a prime number, but then when you hit that number 73, everything breaks apart. And the lesson here is that we need to be careful when we're providing proofs. Examples are not enough. Even if we do many of them and the pattern seems obvious, we still need to provide a general proof that works for any possible case.